Hi, this lesson is about Rolle's theorem and the mean value theorem. So let's start with Rolle's theorem. So Rolle's theorem states that if f of x is continuous on a closed interval from a to b, and it's differentiable on the open interval from a to b, and if f of a equals f of b, then there exists a number c, which is an element in the open interval from a to b, such that f prime of c equals 0. Remember, when we're able to solve this equation, f prime of c equal to 0, we call that value c a critical value or critical point. All right, so let's see if the following function satisfies Rolle's theorem, and satisfies means it's continuous and differentiable, and f of a equals f of b. So that's what it means to satisfy. And if it does, then we'll find the value c that satisfies Rolle's theorem. So that means we're going to solve that equation. All right, so our function is f of x equal to 4x squared minus 8x plus 9. This is a quadratic function, falls under the category of polynomial functions. Polynomial functions are continuous over all real numbers, so therefore it will be continuous on this closed interval. It's also differentiable over all real numbers, and therefore it will be differentiable on this open interval from -1 to 3. So now we just have to check, is f of a equal to f of b? All right, so that means we have to plug in -1 in our function, and then plug in 3 in our function. And if you do, they both work out to be the same value, which is 21. So that third condition of f of a equal to f of b is true. All right, so now let's solve f prime of c equal to 0. So my derivative for this function is 8x minus 8. So if I'm solving for c, I'm just going to call it 8c minus 8, but if you call it x, that's fine. And when you solve that, it's linear. You get that c is equal to 1. So as long as your c falls within the interval, and it does, c1 is within the interval from -1 to 3, you have found the value c that satisfies the theorem. So let's do another one. So if Rolle's theorem applies, meaning it satisfies the conditions, then we will find the value or value c that satisfy Rolle's theorem for f of x equal to x cubed minus x squared minus 6x plus 2 on the interval from 1 to 3. So just like the last example, this is a polynomial function. It's a third degree polynomial. It will be continuous and differentiable over all real numbers, so it definitely will be within that interval. So now we just have to show if f of 0 equals f of 3. All right, so f of 0 means you plug in 0 into the original function. That gives you a value of 2. Plug in 3 into the original function. That also gives you a value of 2. So that third condition is also true. F of 0 equals f of 3. Okay, so now we're ready to take the derivative. F prime of x is 3x squared minus 2x minus 6. So this one is not factorable. It's a quadratic equation, so we can solve it by the quadratic formula. And so in order to use the quadratic formula, you need to know what a, b, and c is from this equation. So a is 3, b is -2, and c is -6. And then we're ready to use the quadratic formula. So instead of calling it x equals, I'm going to call it c equals, so c being the critical point that we will find. So here we have -2 plus or minus -2 squared minus 4 times 3 times -6 all over 2 times 3. So that's your quadratic formula. When you simplify, you end up here at 2 plus or minus root 76 over 6. But root 76 can be broken down into 4 times 19. And we like that product because 4 is a perfect square. So when you take out the square root of 4, you have c is equal to 2 plus or minus 2 root 19, 2 square root 19 over 6. Both of the 2's in these terms will cancel with the 6 in the denominator. So you end up with 1 plus or minus root 19 over 3. So now we need to check. Do both of these fall within our interval from 0 to 3? Probably not, but we need to see if at least one of them does. So if I check c minus root 19 over 3, this is approximately negative 1.21. That is not an element of the interval from 0 to 3. But this one is 1 plus root 19 over 3. That's about 1.79. That is an element of the interval from 0 to 3. So this is our critical value that satisfies Rolle's theorem. Okay, so mean value theorem, it does have some similarities with Rolle's theorem, but it is different and represents something different graphically. So mean value theorem, which I often abbreviate as MVT, just to make it a little quicker to write. So let f be a function that satisfies the following hypotheses. F is continuous on the closed interval from a to b, and f is differentiable on the closed interval on the open interval from a to b. So that part is the same as Rolle's theorem. Now here we do not have to check that f of a equals f of b. That condition is not required. But if these two are true, then there will be some element c that falls within a and b, where f prime of c is equal to f of b minus f of a divided by b minus a. And sometimes it is more convenient to look at this equation in this way. So if you multiply both sides by b minus a, f of b minus f of a equals f prime of c times b minus a. So if I could just draw a visual of what this one here means. If you have a function, f of x, let's say from, from a to b. So this is my a, and this one here is my b. So this one is a, and this one is b. Then the value where their y value would be f of b and f of a. And if I drew a line across this curve, that would give me a secant line to the curve because it would be intersecting at two places. And so the slope of that secant line would be the right side of the formula. And what this theorem is saying is that there is some value c somewhere between f of a, somewhere between a and b, where the slope of the tangent line would be parallel. And so if I were just to kind of guess of where that would be, and drew my tangent line here, this tangent line looks like it would be parallel to the secant line. And remember, the slope of that tangent line at c is f prime of c. So that's basically what the mean value theorem is saying right here, is that the slope of the tangent line at some value c is the same slope as the secant line between the points A and B, where the coordinates with x values of A and B. And there could be more than two C values, but they're saying there's at least one. So here we're going to find the value C that satisfies the mean value theorem for f of x equal to the square root of x minus 1 on the interval from 1 to 5. All right, so let's make sure that the conditions are satisfied. So it is continuous from 1 to 5. So the square root function, this is basically a horizontal shift 1 unit to the right of root x. So it's defined for all real numbers greater than or equal to 1. So therefore, it's also defined from 1 to 5, which is a subset of that. The derivative exists for all real numbers greater than 1, which is okay because the derivative has to exist on an open interval, so 1 doesn't need to be part of that, so that exists as well. So we know it's continuous and differentiable. All right, so now I need to take my derivative, which is this, and I rewrote it in terms of c. So this is 1 over 2 square root of c minus 1. So I rewrote that negative exponent as a radical. But then I set it equal to the right side of the formula, which is f of b minus f of a. So f of b is f of 5. F of 5 is 5 minus 1, which is square root 4, which is 2. And f of 1 would be square root 1 minus 1, which is 0. So that's why in the numerator I have 2 minus 0, divided by b minus a, which is 5 minus 1. So when you simplify the right side, you are basically solving this equation. And if you cross multiply, the 2's will cancel and you end up with square root c minus 1 equals 1. Square both sides and add 1, and you get that c is equal to 2. 2 falls within this interval, so that is the answer. All right, let's do another one. We want to verify that f of x equal to x over x plus 2 satisfies the hypotheses of the mean value theorem on the interval from 1 to 4. And we need to find the number c that satisfies the mean value theorem. Okay, so this function is continuous over all real numbers except at -2. So at -2, you'd have a vertical asymptote, and so the function would not exist at -2. -2 does not fall within this interval, so we're okay. It is continuous. It is also differentiable on this interval from 1 to 4. So just as I mentioned before, if you take the derivative and you use quotient rule here, you end up with 2 over x plus 2 squared. Again, the derivative only doesn't exist at -2, which is again outside of that interval. Okay, so we are ready to set up our equation for the mean value theorem. So I have the left side, which is my derivative, and you can write it in terms of x or c, it's up to you, is equal to, and now using the formula, it's f of 4 minus f of 1 over 4 minus 1. So when you're plugging in on the right side, you are plugging into the equation itself. So what is f of 4? That's right here. That's 2/3. What is f of 1? Plug it in here. That's 1/3. So that's how we get to our next line. This is 2/3 minus 1/3 divided by, and 4 minus 1 gives you 3. Okay, so 2/3 minus 1/3 is 1/3. Divided by 3 is the same as multiplying by 1/3. So your left side has stayed the same, but the right side simplifies to 1/9. So now I need to solve this equation right here, which is basically a proportion. So I'm going to cross multiply. And when you do, you get x plus 2 squared equals 18. Then I'll use the square root method to solve it. So I take the square root of both sides. So the left side becomes x plus 2. And on the right side, you have to remember to put a plus or minus in front. And 18 reduces to 9 times 2, which is plus or minus 3 root 2. Subtract 2 from both sides, and you get x is -2 plus or minus 3 root 2. Okay, so that means I have two potential answers. I have -2 minus 3 root 2 or -2 plus 3 root 2. Well, the first one will definitely be a negative result, so that definitely does not fall within the interval from 1 to 4. And the second one if you approximate what that is, it's 2.24 units, which does fall within the open interval from 1 to 4. So you have found your value that satisfies the mean value theorem. Okay, here's another. We want to verify that f of x equal to e to the negative 2x on the interval from 0 to 3 satisfies the conditions of the mean value theorem, and then we'll find c. So f of x is continuous and differentiable. E to the negative 2x is continuous and differentiable over all real numbers. So it is continuous and differentiable on that interval. So I'm ready to take the derivative and set it equal to what the mean value theorem states. So to take the derivative of my function, I have to use chain rule. And so that'll give me negative 2 e to the negative 2x. And then remember, the right side is f of b, which is f of 3, minus f of a, which is f of 0, all over 3 minus 0. So that's the right side of the formula. All right, so when I plug in 3 into the original function, I get e to the negative 6. When I plug in 0, I get minus e to the 0 divided by 3. Remember, we eventually need to solve for this variable x. So I'm going to divide both sides by negative 2 to get rid of this. So it goes away from the left side, but the right side, my denominator becomes negative 6. So because I have that negative in the denominator, I just multiplied numerator and denominator by negative 1. So I end up with 1 minus e to the negative 6 over positive 6. But now I need to get that variable out of the exponent. So I'm going to use my natural log, which is the inverse function of the e function. So I have natural log of e to the negative 2x equals the natural log of 1 minus e to the negative 6 over 6. All right, so this left side just becomes negative 2x. The right side stayed the same, but I'm not quite done. I still have to get rid of the negative 2, so I multiply both sides by negative 1/2, and I get x is equal to negative 1/2 ln of 1 minus e to the negative 6 over 6. So this is an exact answer. It would be probably pretty difficult to guess what that would be to make sure it falls within your interval. So if you use a calculator here, you would get that value is approximately 0.897. And remember, our original interval was from 0 to 3. This falls within 0 to 3. So you have found the value that satisfies the mean value theorem. All right, so here's going to be a slightly different approach to using the mean value theorem. So we will use the mean value theorem to determine how large f of 2 can be, given that f of 0 is negative 3 and f prime of x is less than or equal to 5 for all values of x. All right, so if you recall, when I first presented mean value theorem, I gave you the formula that we've been using all along. But I also said that if you multiply both sides by b minus a, you will get this second version of it. So remember, we're trying to figure out how large f of 2 can be. And you are given some information about the derivative, and you are told something about the other value where your function exists at 0. All right, so if I plug in the numbers I know, this would be f of 2 minus f of 0 is equal to f prime of c times 2 minus 0. But I know that this value is less than or equal to 5. So my equation will become an inequality. So I have f of 2 minus, now remember f of 0 is negative 3, so I replace that here. So f of 2 minus negative 3 is less than or equal to, and then f prime of c is 5 times, and this one is just 2. All right, so remember, I'm trying to answer that question, so I just need to isolate it. So I get f of 2 plus 3 is less than or equal to 10. Subtract 3 from both sides, so that means that the maximum value that f of 2 can be is 7. So f of 2 must be less than or equal to 7. Okay, so that's it for this lesson. Give the homework a try. Good luck.